Hi, I'm Pete Pedersen, Pepco's Emergency Preparedness Division, and you're about to see a live line safety demonstration that we use to talk about electrical safety for first responders.
The first thing we're going to do is talk about that message of safety that I mentioned earlier. Mr. Hashmall, Dean Hashmall, who is our senior safety coordinator, but also spent over a decade in overhead lines. He's wearing PPE, which is personal protective equipment. All of our overhead and underground personnel wear it, all of our field personnel wear it. It's designed to keep them safe. He has on what are called dielectric boots, not allowed to support combustion, to allow for a direct current to get into his body. That was good, wasn't it? Yeah. FR clothing, pants and shirts. So they're designed not to support combustion. There you go. Sleeves and gloves. These sleeves and gloves are rated for 20,000 volts. So theoretically he could work that, but we don't do that. We always have at least two means of protection. So you'd see he's got his gloves and sleeves on. He's also holding what's called a hot stick. That hot stick is specially designed and treated fiberglass. It's rated for 100,000 volts per foot. So again, theoretically he could work 600,000 volts, but he wouldn't do that. And finally, he's got on his hard hat and safety glasses. This is the minimal protective gear that we wear. Because as I mentioned earlier, a lot of times these guys are working this stuff. One phase may be dead, the other two are energized and in. So if you come in contact with those, obviously it's potentially damaging or life-threatening. So with that, the first thing we're going to do is talk about what causes a power outage. And as we mentioned earlier, that can be a variety of things, from our weather we see here today to a pole strike or a lightning strike. What Mr. Hashmall is going to do here is going to cause a fault on the system. Now, as I mentioned, this is an energized system, just like you'd see in your house or business. And for the day's demonstration, the light represents that we have current or energy into the system or into your house. When we cause a fault, that light will go out, and then we'll talk about a little bit about how we restore that power. So, Mr. Hashmall, this is going to sound like a 12-gauge shotgun blast going off. So if you're a little sensitive to noise, just be ready. Now, I'll give you an idea. That's a 2-amp fuse. We don't have 2-amp fuses on our system. Nothing that small. So if that was on our actual system, it would have been a lot louder. We would actually have been flying past you in an attempt to get a little bit away from it. So a lot of times when people call us and say that they've heard a transformer explode, 9 times out of 10, it's actually a fuse exploding, and there's an associated arc with that and some flame. And so they associate that with being a transformer. In reality, most of the time, it's a fuse. So now what Mr. Hashmall would do, we'll get our complaint would go into our system. It would go to our control center. They would dispatch that out over what are called MDTs, mobile dispatch units, to our trucks. We would send the truck to the location. The first thing they would do is go to the location where the fuse was blown. He's hung here what's called a keep out or tag. And that's so that no one comes behind him, sees that fuse open, and tries to close it in. That can be a problem when there's mutual assistance coming in to help us. Now what he's doing is hanging what's called a set of portable grounds. The reason he does that, as we've mentioned, this is a 3-phase system. The inside phase or middle phase, B phase, is dead. But outside, A and C phase legs are in and hot. So if a tree limb were to come down and land on one of those hot phases and then cross to the dead leg, all that energy could track down to where he's working and injure or kill him. These portable grounds simply gives him a place to work safely, and that's one of the things he's doing. He'll remove the cause, remove the grounds, and then communicate through this whole process with our control center as he's putting everything back. Now, what just took him about 2.5 minutes to do on our system can take hours. A lot of times you'll hear customers say, well, I saw the truck go up and down the street 2 or 3 times. I still don't have power. The first truck roll is to identify where the fault was, blown fuse. The second truck roll was to put up the first set of grounds, then to come back down and put the final set of grounds up. And remember, he's got to set a truck up like that overhead truck down there, and many times that can take as long as 15 to 20 minutes just to set the truck up. Once he's restored all this, he'll get on the radio and communicate back with our control center, tell him he's prepared to close this fuse back in. If everything operates correctly, the lights will come back on. And we have power back. If you notice, just real quickly, another safety topic, if you noticed as he closed those in, you noticed he ducked his head. These fuses do routinely fail. They can fail, and if they do, they have that arc that we talked about. If you're looking at that, it can cause temporary blindness and flash burns. So again, always safety is paramount in everything we do. To give you an idea of the power of some of this stuff, it's just a standard brick. Overhead line came down in the customer's yard, laid on the brick, and essentially melted it, turned it to glass. It crystallized it. That's how much heat was involved. It actually took that brick and turned it into molten glass and melted it. So when you see a down power line, so many people tell us, well, you know, I'm tired of waiting for Pepco, so I moved it with a stick or a broom, because it wasn't flopping around. Well, it was the grace of God that kept them from being injured, because you never know when that's going to become energized. This looks like a piece of asphalt. It's actually from a customer's yard in Upper Montgomery County. Same type of line came down. There's so much heat that it solidified the minerals in the ground and turned them to basic rock. This is nothing more than dirt that we dug up from a customer's yard. That's how much intense heat and power is associated with this stuff. If you're not trained, it takes a minimum of 8 years to become a lead lineman for Pepco at high voltage training. If you don't have that training, you've got no business getting near our wires. Next thing we're going to do for you is draw an arc. As I mentioned, some of those arcs have been measured as high as 20,000 degrees. Firefighters' gear, Larry, is about 1,500 degrees for protection. Nothing they wear, no equipment that you can buy is going to protect you from this stuff. As you'll see here, you'll see as he gets close to this, and another misconception is that you have to, if you get close enough to power lines, they'll reach out and actually grab you. That's false. But when you come in contact, they do a very good job of staying with you. So what you'll see here is as he brushes past this buckle up there, you'll see an arc. It'll do a very good job of following this piece of wire until he breaks enough airspace between it. Just trip that transform. Yep. So what you saw there was an energy or electricity trying to do what it always does, seek a path to ground. If you give it a path to ground that has least resistance, your body, the human body is a great conductor of electricity. It will seek that path of least resistance, and you don't want to be part of that. We're going to do this one more time. We'll draw it one more time. Pay close attention to the color there. It was opaque or a little bit of a blue. The next part of this demonstration will show you something that's a little different. When there's something there that burns that will support combustion, whether that's a tree limb or the human body, you'll see a much different arc. It'll be an orange flame, orange arc. So we do this a lot for firefighters, police officers in training to make sure that they understand the importance of staying clear of this stuff and communicating with us. And we use a hot dog. And the reason we do that, it's a little bit like the human body, a little bit of fat, a little bit of gristle, a lot of water. And we represent what could potentially happen to your hand or someone, member of your team. So what you'll see here is you'll see a different color arc. You'll see the hot dog, that the tissue on it will be blown apart. There'll be damage on the inside. The heat from this actually causes tremendous damage internally also. Electrical burns are considered 4th degree burns. They burn from the inside out. So your organs have a tremendous difficulty with all the energy and the heat that's transferred from an electrical injury. Now, we mentioned earlier about his PPE. You don't have a pair set of gloves. Those rubber gloves, I'll show you something here real quick. So this is a rubber glove over top that hot dog to offer some protection. But there's a pinhole in the top of this glove, and the reason we demonstrate that is to show you that our guys every morning before they go out to do what's called a roll test. That roll test could save their lives because they'll roll a glove up like this to see if it holds air. If it doesn't hold air like that, it's trashed, because even a pinhole or a crack is a spot where that electricity can travel that could injure or kill them. So what we've done is created that gap in here, that breach in the glove, and what you'll see is it'll track right through that rubber. Notice the different color? That's because there's something burning. There's a definite, distinct smell to it. Tripped it. So we'll do it once like that, and then we'll do it without the glove and show you. As you can see, the tissue damage has been done. The top of that hot dog has literally been blown off. There's damage down inside. All that tissue would have to be removed. All this internal damage here. So as you can see, it represents a tremendous amount of bodily injury that would have to be surgically repaired, and that's if you survive the injury. Many times when they transport an electrical contact injury, their vitals are good. they're responsive, and as you get them to the hospital within 24 to 36 hours, they start to have their organs shut down because of the amount of mass of heat that's been induced to their organs. They can't take that, and they subsequently start to shut down, and sometimes the individual passes away 24 to 36 hours later, even though they survived the initial contact injury. So now he's going to do the same thing, only without the glove as protection. And then we can certainly pass this around to anyone who'd like to get a closer look at it. It has a very distinct copper smell. The wire will actually penetrate the skin with the copper smell. And we can certainly offer it up to lunch, too, for anybody who'd like to. Well, in 10 years that Dean and I have been doing this, we've had one person do that and actually keep it down. Just a little note that I thought you might be interested. Look at the intense color, because all that is burning that tissue.
How many volts?
It's a good question. How many volts do you think's running in the trailer? A couple thousand?
Probably not that much.
Actually, it's 110 volts that we're taking through a transformer and stepping up, but there's 7,600 volts off the top of that trailer. Yeah. So
Why do you want to emphasize portable generators and the danger?
that's actually a really good point. People who buy portable generators, it's great, but a lot of people don't want to hire a contractor or electrician to hook it up properly. So someone's told them, you know what, you can just plug it into your dryer outlet and backfeed. Well, the problem with that is you're also backfeeding our system. So as our responders arrive on the scene and they think it's de-energized, the generator is actually backfeeding our system, could injure a first responder or utility worker. So that's a great point. That's a real critical safety issue that people have to understand about backup generators. Again, awful lot of damage, and it's a split second. At 186,000 miles per second, by the time you've seen the arc, by the time you've seen the flash, the damage has been done. And the other thing I will tell you is the gear that Mr. Hashimoto has on and the gear that you will see these other gentlemen will use later today, it's a very nice environment today to have it on. But if you can imagine in 12-degree weather, up on 60 feet in the air, with all your gear on and those gloves, trying to turn a bolt, trying to do work, flip that and make it 95-degree weather with 90% humidity. I've seen these people take their gloves off after a half an hour and pour the moisture out of them. You know, staying hydrated is a big issue for us because the environment that we work in is it's really dangerous, and not to mention it can be very unforgiving. So you're working in some of the worst conditions imaginable. So the next time you see them, maybe give them a little bit of an understanding, a break, that they're doing a tough job, just like any first responder, but they're very committed to doing a very, very good job, but they have to maintain their safety at all times. So with that said, if there's any questions, we'll try to take them. But we thank you for your patience and your time, and we hope you enjoy the rest of the demonstration. Our overhead people are going to give you a great demonstration in the training yard. You'll see a little bit about how difficult it is to get geared up, to get set up, and get up on the pole 60 feet in the air and still be able to do your work. So with that, thank you very much. Have a great day.